Okay, right, so we're going to take a look at paper 2. I'm doing it the same way as I did the other one. So with the other paper, the first paper, I went through this, I sort of did all the questions blind, I talked you through my train of thought and perhaps not wrote a full answer, but wrote an example answer, some bullet points, etc. And then we looked at the mark scheme and we compared and so on and so forth. So I hope you found that useful previously, and I'm going to have another go at the second paper. It's worth noting that the second paper has changed a reasonable amount this year. Previously there was a pre-release document and you sort of solved the problem and answered questions about it. Now you have probably a few more questions akin to part B of the previous paper, so theory questions, and then you have several programming questions rather, or perhaps just one big question towards the end of the paper. And that's a special challenge all of its own. Anyway, right, let's take a look at this. So the first question here, for pseudocode descriptions, 4 pseudocode descriptions and 5 pseudocode statements are shown. Draw a line to link each pseudocode description to the most appropriate pseudocode statement. Some pseudocode statements will not be used. Pseudocode description and then pseudocode statement, sorry. On the left, you've got these various statements, and on the right, you've got the pseudocode example. Where's my mouse gone? I need to get my pen. There we go. Right, so a loop that will always iterate at least once. So next, for to next. It seems unlikely. This is count controlled. I suppose you could set it so that it happens just the one time, but it's not always going to happen at least once. If then else, that's not a loop. While, do, end, while, actually that might not iterate at all because the condition might be checked, well, will be checked at the start, might not be true. Case of otherwise, end case, again, this is not always, it's similar to an if statement. And the last one, repeat until. This will always happen at least once because there is a condition being checked at the end of the repeat. So, that. A conditional statement to deal with many possible outcomes. Well, here we're thinking conditional statement, many possible outcomes. We're either thinking if or case. I'm thinking case because an if statement sort of deals with one thing at a time, whereas a case statement deals with all the possible outcomes sort of simultaneously. So I'm going to go case. Next, a loop that will always iterate a set number of times. That's going to be a for loop. It's count controlled, so up we go. And the last one, a conditional statement with different outcomes for true and false. In this case, I'm thinking if statement. It's going to do different things based on different conditions. It's not talking about iteration, it's talking about conditional statement. So if statement. Let's check the mark scheme. So there you go. A loop that will is repeat until. A conditional statement to deal with as many possible outcomes is case. A loop that will always is for. And a conditional statement with different is if then else. Easy peasy. Next question. Using a single loop, write an algorithm in pseudocode to output 50 names that have been stored in an array, name, square brackets. Okay, so a couple of things about this. Using a single loop. So I'm thinking for or while, those are our only options really. Write an algorithm in pseudocode to output 50 names that have been stored in the array. So I don't see any reason why you couldn't do this with the for loop, but I feel like a conditional loop here rather might be a little bit more practical. So we're going to be doing something 50 times, and if I'm going to use a keep saying count controlled conditional loop, I need to set the condition against which I'm going to compare. So first thing I want is going to be a count variable and I'm going to want that to be equal to 0. Now, you could do this the other way around, actually. You can make it count as equal to 50 and count down, but counting up seems more natural to me. And then you want your condition, right? So your loop. So we're going to have a while loop, obviously, as we mentioned. And we're going to continue to repeat whilst count is less than 50. Now, I'm used to writing pseudocode where I would say, for example, count equals 0, and then count while count is less than 50, and then just move on, because my pseudocode is sort of based on my knowledge of Python. But Cambridge sort of like you to write in a distinctly different style. And if you look at their pseudocode guide, they'll do things like while do rather than simply while followed by a condition. So I'm going to put that do in just here. I'm going to put a colon because I like them. Then we need to do the thing. So they just want us to output names, right? So what we're going to say here is we're going to have output, and then the thing that we want to output, well, we've got this list called names right here. So we're going to have names square brackets. Now, in the square bracket needs to be the index value. So in hindsight, actually, it probably would have been better to do this as a for loop, because you more naturally have this this index value coming up as part of the loop. But I haven't done it that way. I've done it with a conditional loop. So the condition that's going to change here is going to be count. So in here, I'm going to put count. We then need to increase count each loop. So there's a few ways that we can do this, but let's go count plus equals 1, so we can count up each time. And then again, I tend not to do this when I'm writing pseudocode for myself, but Cambridge like you to end that while. Now, I have in the past advised my students not to worry too much about it. You should get the marks anyway, but I've seen recently that marks have been applied for while, do, end while, and that being 1 mark. So you are as well to add that end while in, just to signify that the loop is coming to a head. Right. Let's take a look at an answer. All right, so actually very, very similar to what I wrote. Count equals 0. While count is less than 50, do output the name, and then our index is that count. That could be anything. It could be anything that you please there, as long as that variable appears there. And count is equal to count plus 1. I did count plus equals 1. That's the same thing. And then end while. Now, awarding marks here for an appropriate loop or appropriate loop controls. So you have something which is going to prevent it from iterating more than 50 times. They're giving you a mark for reading from the array. So that's the name count part, and they're giving you a mark for output from array. The last 2 points can be in one statement. See the example. So it's just this line here. So what they're suggesting is you could potentially have a variable that stores name equals count, and then you output that variable. Slightly long-winded way of doing it, but an acceptable one apparently. Next question. Describe the purpose of validation and verification checks during data entry. Include an example for each. So validation check and verification check. So this is something that's really, really easy to get the wrong way around, and I frequently do get the wrong way around. Validation and verification are similar. With validation, we are checking to make sure that what has been entered is acceptable. It meets the requirements, it meets the rules. We're not checking whether it is true or whether it is the correct answer or not, just mainly whether it is the right data type. Verification is where we're doing the opposite of that. We're not necessarily that interested, well, in fact, that's not fair, but we are looking at whether the data is true, okay? And it's much more difficult to do for a computer. So validation, we have any number of checks here. So what we want to do first is say what it is. So checks the data is acceptable. Okay. Second point here, we want to say how we would do that. So for example, using a format check. Okay, format check being like name @symbol followed by company .extension. Something like that would be a format check for an email. Right, validation check. Here we want to check, so what it's doing is checks the data is accurate. See what their choice of words is later. They might say things like data is what was intended, etc. And then how you could do this is you could have a double entry check. Okay, so this is where it's like when you reset a password, you type it in once, you type it in again, and it's just to make sure that you haven't had a typing error. Okay, so what they said. So 1 mark for the description or 1 mark for example. So to test if the data entered is possible, reasonable, sensible, I hope they would accept acceptable there. A range check tests that the data entered fits with the specified value. Allow any correct validation check as an example, so range, length, type. So I said format, and that's there, so perfect. Verification, to test if the data input is the same as the data that was intended to be input. I think so. I said something about accuracy there, so hopefully that's similar. And then data entry checks. Double entry check expects each item of data to be entered twice and compares them. I perhaps didn't go into quite that level of detail, and maybe I should have done, but they do say allow any correct verification check, and they say double entry as an example. So hopefully what I wrote they would consider to be acceptable. Next question. Right, so tick one box to show the named section of the program that performs a specific task. A file, no, it's about saving things. Function, that could work, that's a specific task within a larger program. Parameter, this is a piece of information that you plug into a function, so it's not going to be that. Process, I would say this is a broader thing, so I'm going function here. Let's have a look. And they say B. Perfect. Okay, next question. Question 4. A satellite navigation system is an example of a computer system that is made up of subsystems. Part of a satellite navigation system allows the user to enter details for a new destination or select a previously saved destination. Displays directions in the form of a visual map or as a list. Draw a structure diagram for this part of the satellite navigation system. So, structure diagrams are these things which kind of like you square here, and you've got these sort of arms coming out, and basically they demonstrate, you know, how something can be broken up into smaller subproblems. Okay, so we're looking to produce one of these for this particular task. Now these strike me as a little bit intimidating because it's not something that you're probably going to spend a huge amount of time doing in class, but they're not wonderfully difficult, and that's probably why you haven't spent a lot of time doing them in class. So first thing is the top box wants to be what you're doing. So this is a navigation system, so I'm just going to say, oops, there we go, just do it again, right. This is going to be a sat nav, okay, and I'm going to put this in a box, worst box ever, but there you go. And then I want to think about the things that can be put into this. So part of the satellite navigation system allows the user to enter details for a new destination or select a previously saved destination. So those are our only inputs. So we've got inputs, they're both destinations, and they're different types of destinations though. So there's a breakdown there. And then displays directions in the form of a visual map or as a list. So we've got outputs, and there are two of them. So this is pretty straightforward stuff actually. What we're going to do is we're going to come out, across, down a little bit, and we're going to say, I'm just going to say destination. Okay, maybe I won't make such a big deal about my box. There you go. And then off of this, I'm going to have two other things. That's going to be previously and saved. So I'm just going to say prev and save. Now obviously you should not shorten things in your exam and so on and so forth. I'm just doing it because this tablet pen thing is a little tricky. So on this side we're going to have our output directions. So something like this, there's my directions. And they come in two forms. Form number 1, map, and form number 2, list. Now, I don't think as it stands right there, I'm necessarily presenting this clearly enough to get all of the marks, but I have covered all of the bases, and obviously you would do this more neatly in your exam. Okay, so let's take a little look. There we go. So we get 1 mark for hierarchical structure. So basically just having the legs in the boxes in roughly the right place. Mark, easy mark. 1 mark for suitable names for the subsystems. So you're not getting a mark here for the top box, by the way, just input, destination, output, directions, so on. 1 mark for identifiable inputs. So we've got new destination and save destination, and 1 mark for identifiable outputs, so map and list. And they actually did exactly what I did, so that's kind of nice. And that should be all your 4 marks. I would like to think that if that was a little neater, I'd be getting all 4. Okay, next question. Question 5. So this isn't actually quite laid out the way it was on the exam paper because it wouldn't fit on my slide, so excuse that. An algorithm has been written in pseudocode to input some numbers. It only outputs any numbers rather that are greater than or equal to 100. The number 999 is not output and stops the algorithm. You can see the algorithm there on the left. So it says, identify 4 errors in the pseudocode and suggest corrections. So first thing to do is obviously have a little look through it and look for anything obvious. And the first thing that catches my eye is around number. So input number while numbers is not equal to 999 if number, right, so there's a mistake there. So I'm going to say error number 1 is on line 2, and it's something like, I don't know, numbers should be number, something like this. Okay, probably not the worst idea ever to match the font, match the case rather. So to fix this, obviously you want to say the whole line. Don't just jump in with a little piece of it. Say the whole thing. Personally, what I would do is I would delete the S because it's just a little bit less effort, isn't it? But ultimately it doesn't matter. You could correct input so that it was number. So input numbers, or you could change numbers so that it was number. But if you did the former rather than latter, you're going to have to change number in the first line and in the third line. So I'm going to say that the correction should be while number is same symbols 999 do. Okay. Next error. So I'm looking at the question here. It only outputs any numbers that are greater than or equal to. Well, if number is greater than 100, is going to exclude 100. That is not inclusive. So I would say line 3. And I would say something like number less than 100 should be, and then I'm actually going to run this into my corrections, number greater than or equal to 100. I think I actually said less than a second ago. I do know which way around it goes, I promise. We do a correction. I would always recommend doing the whole line. So if number is greater than or equal to 100. And that would be my second one. So one of the problems here is actually back on the first line again. You input this number, but you only input it once, yet we test it 1,000 times near enough. So actually we need to think about that. We need this input to be inside the loop somewhere. So I would say line 1 is a problem. Input needs to be in the loop. So I would say it needs to be after the if statement. So you do the process and then you enter a new number. So input number needs to be after the end if, something like this, right? The reason for that is we are going to set something at the beginning, we're going to check it, if it's acceptable, we'll start. If the number is greater than or equal to 100, then we're going to output that number, then we need to ask another one, okay? So we need that input to be inside of the loop. Fourth error is a little bit of a strange one actually, because I think that it's the very last line, output number, is superfluous. You don't need it. Because you output it each time you do it. All that output is going to do is output the very last number that you enter. So what's that? 2, 4, 6, line 8. Output not needed, deleted, something like this. Right, I'm not sure that's my finest work, but let's take a little look. So they said numbers should be number, so a little shorter than me. If number is greater than 100, should be if number is greater than or equal to 100, so almost the exact same. Notice they've done the whole line. Input number is missing from inside the loop. Insert input number after end if statement, so they did the exact same process as me, but I think you would be safe saying it needs to go inside the loop. More or less anywhere inside the loop would give you a more acceptable solution. And finally, yeah, there you go. You don't need that other output because you're saying it twice. Oops. Right, next question. Right, write a pseudocode statement to change the corrected algorithm to output all numbers between 100 and 200 inclusive. You do not need to rewrite the whole algorithm. So they're just interested in the bit which is going to make it deal with different numbers. Okay, so first of all, let's figure out what that part would be. So we go back. So the part that's controlling this is if number is greater than 100. And we want it to deal with between 100 and 200. So it's the if statement that we want to change. So we're going to want to change that to if number is greater than or equal to 100 and number is less than or equal to 200. That should do it. Most common mistake here is that we leave that out, okay? Because that's the way that we speak. We would say if the number is greater than or equal to 100 and less than 200, or less than or equal to 200. The computer doesn't work like that, so if you leave that out, you will lose the mark, okay? So you need to watch that one. Let's check the mark scheme. So the mark scheme says 1 mark for both ends of the range and correct inequality symbols. So they mean the less than, greater than, so on and so forth symbols. 1 mark for and, or you could do this with nested ifs, didn't think of that. The test should be if number is greater than or equal to 100 and number is less than or equal to 200. So the last one is just an example, but you're really getting the marks for the first two. Okay, question 6. Right, at GCSE, these are not too bad at all. These are, once you've got your eye in with them, they're pretty straightforward things. I like to almost read them like a sentence and write them out as I do them. There's lots of different ways of doing this, but for GCSE, this method will work. So, what I would do is I would say X, A and B, right? So A and B. So between those two, I'm going to have an and symbol, right? So it's this sort of D-shaped symbol, right? And you must have your inputs, okay? They can be untidy, doesn't really matter, but you have got to have those inputs and you've got to have an output. There is a fairly good chance now that you've ticked off a mark, okay? That is this section, done. So we've got A and B, or is the next one. So or is slightly difficult to draw with this tablet thing, but a bit wonky. But the thing about or is you want it to have a curved back and a pointy-ish nose, okay? They will allow you to have a dodgy drawing, you just need to make sure that the back is curved, okay? So there's my or, okay? So A and B, or, then you have B and not C. So we're not quite gonna read this in order, it's not A and B, or, but we're gonna have B coming up here, like this, into an and gate. Okay, and that is going into the or, like that. Okay, now an AND gate requires 2 inputs, and before the C comes a not, right? So a not is a sharp triangle, it has got to have this spot on the end. Okay, and we're going to go like that. Now, I said you can kind of read this like a sentence, and here's how. A and B, or B and not C. So it doesn't work perfectly like a sentence, but it kind of works, right? There's a little bit of structure to it. Okay, and that finishes it up. Now, if that doesn't really work for you, deal with the parts in brackets first. I mean, that's what the brackets are there for anyway. So A and B, it's just an A with an AND gate in between it, super easy. And then B and not C, this is going to be the B input going into an and ultimately the C input going into an and, but the not is going to sit between that gate and the C input, okay? And then or is going to be your last gate. Now, this one is often the easiest one to deal with. When you get to A-level, it's a little different, but for GCSE, that one is just going to sit between the 2 clauses. It's going to be the last gate, okay? So as long as whatever you've done for A and B, and whatever you've done for B and not C, both plug into an OR gate, you're on the money. Mark scheme looks a little like this. You can see how they've awarded the marks. They've given 1 mark for each correct gate with correct inputs as shown. So it's not just getting the right gates, they need to have the right inputs. But you could have written them in a peculiar order or something like this and still pick up marks. Okay, so 1 mark per gate. I've done both of those ands, the or and the not. Piece of cake. Next question. Right, here you've got to complete your logic statement, your truth table, right? And this is genuinely going to be much easier on the exam paper, where you can see the diagram and you can see the table and so on and so forth. Okay. Now, what's going to be quite easy here is where we have no inputs, we will have no outputs, right? So if we go back and have a little look, if you have 0 coming into and you've got 0 coming into and from the other side, it's going to produce a 0 out the other side, right? The same thing is here. If you have a 0 coming in here, it will produce a 1, but you need a 1 on both sides. 0's coming in here, it's going to give a 0 out the other side. So easy one is all of the zeros, that's just going to be 0. Incidentally, you don't typically get marks for working on this question. This working space is exactly what it sounds like. It is just for working things out. You use it, you don't use it, it doesn't make any difference. Right, now if we have nothing for A, nothing for B, and something for C, what we will wind up with is nothing going into our first AND gate, and nothing going into our second AND gate either, because both of these are going to be 0. Now if we plug a 1 into that NOT gate, that's going to produce a 0. So you've essentially got a 0, 0, 0, 0 there. Right, here we've got nothing for A, something for B, and nothing for C. So if we come back, we've got nothing for A and something for B, which is going to give us a 0 out of here. We have something for B, and we have nothing for C, but the C is going to produce a 1. If 0 goes in, a 1 will come out. So you've got 1 and 1 going into this gate, which means you'll have 1 coming out. The OR gate, if it accepts a single 1, it will produce a 1 out the other side. It's one or the other, or both. So this is going to give you an output. So we have a 1. Okay. 0, 0, 1. I was just trying to be tidy there. Right. Same here. We've got nothing for our A. We've got something for B, but we now have something for C. Now, this is going to flip things on its head, because this is actually a 0. So we would get nothing. Here, we've got 1 for A, we've got nothing for B, and nothing for C. This is actually the same as this. Okay, well, at least it is on the face of things. It seems the same, right? The trouble is that when you come back over here, we've got a 1 going in there and a 0 going in there, so that's 0. We've got a 0 going in there and we've got a 1 going in there, so that's 0. So there's going to be 2 zeros there. So that's going to give us 0 out the other side. 1, 0, 1. So 1 and 0 is going to give us 0. 0 and 1, which is actually 0, is going to give us 0, so it's going to be 0 out the other side. Right, 1, 1, 0. Whoops. So you have a 1 and a 1, that's going to give us a 1. We have a 1 and a 0, which becomes a 1, that's going to give us a 1. So 2 1s going in here. 1 or the other one or both gives us a 1 out the other side. So this would be 1. And a 1, 1, 1. Oops. So we've got a 1 going in and a 1 going in. That's a 1. We've got a 1 going in and a 0 going in because of the NOT gates. So that would be a 0, but we only need 1 to get a positive outcome. So 1. And that should be your answer. Okay, so 0, 0, 1, 0, 0, 0, 1, 1. So here you go. There's your answer. 0, 0, 1, 0, 0, 0, 1, 1. Look at the way that they award marks though. You get 4 marks for 8 correct outputs, 3 marks for 6 or 7 correct outputs, 2 marks for 4 or 5 correct outputs, and 1 mark for 2 or 3 correct outputs. So you've got to have at least 2 correct in order to get yourself on the board. Okay, This is slightly different because sometimes they mark these in bands, but this is a bit more favourable. Okay, next question. So these are not my favourite. They're not terribly difficult, especially once you get your eye in, but they are quite time consuming. So where on some areas of the exam you want to be aiming for around about a mark a minute, others you're going to do a little quicker than that. This, you're definitely not going to do this 5-mark question in 5 minutes. It's just a little time consuming. So this is somewhere where you want to spend a bit of extra time, okay? Anyhow, right. So all you really need to do with this is plug in the variables that you have, dry run through the program and write down things as they happen, okay? So where we're going to start with is we're just going to start with the first box. So the first box is flag 0. Now they've already done the first row for you. What they're essentially saying, you start with these values. So after that, on the second row, we're going to say our flag is 0 and our count is 1. Okay. Then is name count greater than name count plus 1? So all they're saying is this greater than this, right? So J does come before A, sorry, does come after A in the alphabet. And when we look at this style of question, later in the alphabet is more valuable, right? So if you think of A as being 0, then J is going to be about 10, okay? It's going to be about halfway through, so it's a higher value. So the answer to that is yes. The next thing we're going to be looking at then is temp name count, right? So at this point, Jamal, who's the name that we're looking at, is going to make his way into temp. So that's way over here. Jamal. Okay. Name count is equal to name count plus 1. So name count is still Jamal, so we've just duplicated him. Name count plus 1 is Amir. So in here, oops, we're going to have Amir. Name count plus 1 is equal to temp. So temp is Jamal. And then flag is going to be 1. Okay. Now, I tend not to fill out anything that doesn't change. So in this case, Eva and Tara aren't being touched. They're not being looked at in this scenario at all. Not at this point anyway. So I would tend to leave those blank. I think it is case by case, and it is entirely up to you what you decide with that. Personally, I leave it blank. Count is going to increment by 1, so count is equal to count plus 2, plus 1 rather, so it's going to be 2. Is count equal to 4, or count is not equal to 4, so we go back to the start and we ask the same question. Now, count is obviously incremented, so now we're not looking at name 1, we're actually looking at name 2. So what I would do here is I would add in Amir. I wouldn't add in Jamal. Jamal's the one that we're looking at next. So is name count greater than name count plus 1? So is Jamal greater than Eve? Well, the answer to that is very much yes. E comes before J in the alphabet. So we're going to put Jamal into the temporary variable again. Right. We're going to say that the thing that we're looking at is now equal to the thing next to the thing we're looking at. So is next is going to be equal to Eve. Name count plus 1 is equal to temporary. So Jamal makes his way in there. That's very bad handwriting. And flag increments by 1. So flag is going to go. Flag doesn't increment by 1. Flag is simply set to 1. So flag equals 1. Count increments by 1. Is count equal to 4? No, it's not. So we're back to the start again. Okay, and this process repeats. Now, the way this is likely to be marked, you should be aware of this. The way this is likely to be marked is it's either going to be marked with deductions made for mistakes or for it to be marked in bands. The other way that it might be marked is for the columns to be correct. So it doesn't necessarily help you to know it, but I think it is useful to know that you could be getting 1 mark for the first 2 rows, for example. The problem with this sort of question is there's going to be an awful lot of repetition. You go through it and you go through it and you go through it. I hope you would agree it's not actually that difficult. I'm going to do 1 more row and then we're going to look at the mark scheme, because otherwise I just do the same thing over and over again. So here, Amir is going to still be there, and Eve isn't going to be changing. Jamal, on the other hand, might be. So is name count greater than count plus 1? So is Jamal greater than Tara? So all you need to do is work out whether J comes before T in the alphabet. In this case, it does. So we're going to say no. And we're basically going to leave everything the same. In fact, what I'm going to do is I'm going to say Jamal, Tara, and Jamal is still going to be in that temporary variable, but for me, as I'm not changing it, I'm not going to add it in. Right? So we've now taken the no option, which just means that this remains as 1 because there's no opportunity to change it, and this is going to go to 4 because of the increment. Okay. Is count equal to 4? Well, yes it is. So everything is going to, the next step is flag equal to 0? Well, that is no. So that takes us all the way back to the start, way up here above the flag and count, and these things are going to be set back to 0 and 1. Now, it's probably at this point not an awful idea to fill this row in. I'm not going to, because it's not changing, and it helps speed things along, but it's probably good advice to complete that row. Okay, so we've now got back to that value, and the process starts again. Okay, that's because it's not yet in order, and this is going to repeat and repeat and repeat and repeat until we have things in perfect alphabetical order, so that the result that you would be looking for in this bottom row ultimately is going to be a 0. It's going to be a 4 because you will have met 4, and then you will have the names in the right order, which is going to be Amir. Eve is actually in the right order, isn't it? Jamal, Tara. Okay, now the reason we haven't got there is because there's been no opportunity up here for us to set flag back to 0. Okay, so for this to happen, you've got to come to this point at least once and say no, so that our flag ends up as a 0. The only other alternative is that it is right from the outset, which it's obviously not going to be. Right, let's take a little look and you'll see the rest of the answer. So here's the answer, and you can see they've filled out every single box except for 3 on the first row. So we'll see in a second how that would impact my mark, my decision not to fill out things that don't change. But they're saying 1 mark for flag column. So you need to have that flag column exactly like that. 0, 1, 1, 1, 0, 0, 0, 0. 1 mark for the count column, 1, 2, 3, 4, 1, 2, 3, 4, easy peasy. And 1 mark for the temporary column. Now, I probably would have lost a mark there because I chose to leave a few blanks because things weren't changing. 2 marks for all correct name columns, or 1 mark for 2 or 3 correct name columns. Now, arguably, I may have lost marks there because I've left blanks, but then there's this last one here at the bottom. Note, repeated values do not need to be written unless a value is rewritten. Okay, so that's probably a good rule of thumb in general. Now, I have to say, Cambridge can be a little unpredictable with such things, but the fact that they've said repeated things don't need to be rewritten unless they are actually rewritten within the program is kind of a useful rule of thumb, right? So all of that Jamal column is not, that is actually being rewritten each time, okay? Up to the point where we don't need to move Jamal anymore, basically up to the row that starts 1, 4, at which point you could probably leave that blank, okay, because Jamal isn't moving up or down the list, okay. So I hope that makes that reasonably clear. That's quite a lengthy and quite a tricky question, but like I say, once you get your eye in with it, hopefully not too difficult. Right, next question. Describe what the algorithm represented by the flow chart is doing. So it's only worth 2 marks. So it's obviously trying to put things into some sort of order. So it's a sorting method. You then want to think about perhaps which sort it is. Now, it's obviously not an insertion sort. It's not a merge sort. It's not any of the kind of weird and wonderful, wacky sorts. The one that seems most applicable here is a bubble sort, because we sort of move through, and it has that telltale disadvantage of needing to go through it one extra time after everything is in order. So I would say that it is a bubble sort, and it's 2 marks, so you're not going to get 1 mark for bubble and another mark for sort. You're going to get a second mark for saying basically what it's trying to do. So you might say something like it's trying to get it into alphabetical order, or lowest to highest, or something like this. You would probably be a little risky saying something like get it into order. It's a little too vague. In this case, I'm going to say order from A to Z. And I think that concludes question 7. Oh, let's take a look at the answer. Sorry. There you go. So we scroll down just a little. Bubble sort, or sorting the names, ascending order, A to Z, lowest, highest, alphabetical order, lots of things there. So long as you are doing a little bit more detail than simply saying it was sorted or put it into order, you should be fine with all of the sensible answers. Next question. So question 8. The programmer has written an algorithm to check the prices are less than $10. These values are used as test data. State why each value was chosen as test data. So this is actually sort of a vocabulary test. You should watch out for any repeated terms. Okay, I'm not necessarily saying they are wrong with a question like this, but just watch out for them, because sometimes you won't get marks for saying the same thing twice. So in the case of 10, right, we want to make sure that prices are less than 10. So you could argue that this is boundary data. You could say something like this price shouldn't be accepted. The best answer here is actually abnormal data, because it falls outside of the expected range. It's not erroneous, it's not the wrong type of data, but it falls outside of the range that we're expecting. So I would say abnormal. Oops. Abnormal data. Right, then we've got 999. I would call this boundary data. It falls exactly on the point of our, in this case, maximum value. It would also be boundary data if it fell exactly on the point of the minimum value. This might also sometimes be called extreme data, and you could make an argument to say that this is normal data. This is something that should be accepted, but I'm going to call it boundary data. Okay, and the last one, 10. I would probably call this erroneous data, but I know that Cambridge is not a fan of this this term. It doesn't crop up all that often, so I'd probably say something like it would be rejected, or wouldn't be accepted. In fact, wouldn't be accepted. To me, this isn't abnormal data, because I'm going to go ahead and assume that they're looking for a floating point number, so 10 point something, 9 point something, 8 point something, and this is obviously a word. So I would say that that's not acceptable data under any conditions. So it's not the right type of data. Let's see what they say. So 10, they have said, is boundary data. or abnormal data, the price should be rejected rather, or the value is out of range. So all those sorts of things we talked about. Boundary or extreme or normal data is there. We mentioned all of those, and I said boundary, and the last one they've said abnormal, which I don't completely agree with, but they've also said it should be rejected, which is the same as would not be accepted, or the value is of the wrong type, which is sort of what I was getting at with my argument that this is erroneous data. Anyway, it's question 8. Let's jump back and take a quick look at question 9. So, question 9, explain why a program might need to store data in a file. So, this is quite an easy one to mess up because oftentimes we think, oh, we are storing things when we're running our programs, but actually the case is often not that at all. We often run the program, store things into lists and things like this, but that is not actually storing things anywhere. Once the program ends, that information is lost. So the reason we might need to save things into a file somewhere is so that it's saved permanently. That's the big picture here. So my first point would be around that. So that data is stored permanently. Something to that effect. Another reason why you might want to do this is perhaps as a backup or as an archive of something. You might want to do this because you want to be able to share something with somebody, or you want to be able to share the outcome of this program with another service. It might also make it easier to move that information from one system to another. So those are the ideas that I'm going to play with. So I'd probably say something like, it means data can be shared with other services, and maybe I'll go with a backup. Something like this. I'm often a bit wary of using backup. Backup strangely doesn't come up all that often, and people use it mistakenly when talking about things like secondary storage. But it is a valid answer in lots of instances. So with a question like this, if you're drawing a little bit of a blank, it's not going to hurt for you to put something like backup or archive down. Right, let's see what they've got. So for question 9, data is not lost when the computer is switched off, or data is stored permanently, which is what I said. Data can be used by more than one program or reused when the program is run again. So I said sharing it with another service, so it can be used with more than one program. It should be a tick. They've said backup or archives, that's perfect. Also, the data can be transported from one place to another, which seems a little bit similar to the second point, but it's there. Right. Next question. Question 10. A function is declared using pseudocode. Tick one box which accurately describes the use of the variable inches. So, answer. Well, inches isn't the answer. It's part of an equation. Call. No, that's not how you call a function. Parameter. Well, parameter is being passed into this function. We typically describe things being passed in those brackets up here as parameters. So that seems very plausible. D, response. Response is something that you might say colloquially, but it's not a technical term at all. So that's completely null and void. So I think the only opportunity here is C. Okay. Now if we jump back over, we will see question 10 is C. Okay, so question 11. This is a database question. They've given you a big database there, which is a little bit intimidating, but actually it's nothing to worry about. First part is state the number of records in the database. So all you have to do is count them. So I've pre-counted, I know there are 20 there. Okay, now the records are just the rows. Okay, so the horizontals, how many films are there essentially in this case? Give the name of the field that we used as the primary key. So the primary key is something that we want to locate in the database, which is going to be unique. Okay, it's going to be unique to that particular record, and for us, that is the cat number. Now, the exam might not always do this, but oftentimes the primary key is going to be the first field in the table. Okay. You're looking for something which is going to be difficult to duplicate elsewhere. So for us, cat number. Right. Now, next part is to state the reason for choosing this field for the primary key. So ultimately, you can say a whole bunch of different things here, but you're going to come to a very similar conclusion. It's unique. It's a unique identifier. It's a unique descriptor. It's a unique something for that particular film. So that's what I'm going to say. It's unique for each record. Okay, and then if we keep on going, it says complete the table to identify the most appropriate data type for each field based on data shown in the database table, so on and so forth. Right, you've got to watch this a little bit here because the data types that are available to you in a database vary a little bit from the data types that you're perhaps most familiar with from programming. So you've got to keep an eye on that because they could throw you a few curveballs and so on and so forth. Things like dates and currencies and so on could be described as a different type of data within a database. For us, cat number is a mixture of numbers and letters. Typically, if we have a mixture of numbers and letters, we're going to call this a string, or we're going to call this text or something like it, because when we have that mixture, we're not obviously going to do any maths with it, so that makes it most obviously a string. Now, I happen to know that they're not keen on the term string when describing text in databases, so I'm going to say text. I think you would also be okay with things like short text and long text and so on. Next is the title. Well, the title it's nearly exclusively, if not exclusively, letters. There's table 19 there at the top, but that's going to be the same thing. So whatever you've written for the first one, we're going to write for the second one. Genre, or genre 1. So jump back up here, genre 1, those are all words, so same again, so not terribly difficult here. And the last one is streaming. So if we go up here and we look at that streaming column, which is this one over here, we've got yes or no all the way down here. Now, yes or no is a Boolean response, right? You've only got two options there. Now, in programming, we will be looking for true or false, but in a database, I think you're okay in this instance to say that that is Boolean. If for no other reason than saying text 4 times is a little boring. So, Boolean. And I think, oh no, there's one more question maybe? Yes. So we complete the structured query language, or the SQL, to return the category number and title for all comedy movies. So you've got select cat title blank 2018, where genre 1 equals. So this is not high level SQL here, this is not a particularly challenging thing, I hope. We always remember select from where. So select from the database where genre 1 is equal to, or we're looking for comedy. And there's an easy thing to forget here. Comedy is text, or it's a string, so we want our speech marks there. Okay. Yeah, and that concludes question 11. So let's take a look at some of the answers. So question 11, there are 20 records. That was an easy one. Our primary key is the cat number. The reason we've chosen it is because it's unique, which is again very similar to what I said. Excuse me. In the table, we've got text, 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 Boolean. They've also said you can have text, which is fair because yes and no are words. And lastly, the blanks from the previous question are for and comedy. Notice speech marks. Okay. Right. Next question 12. Variables x, y, and z are used to store data in a program. X stores a string, y stores a position in the string, z stores the number of characters in the string. Write a pseudocode statement to declare the variables x, y, and z. So this is super easy. A lot of that is a distractor. What you need to remember here is the way that Cambridge likes to see you define things within pseudocode. Now, if you happen to be watching this from a different exam board, your exam board is likely to have a pseudocode guide. Sometimes these exam boards hold you quite strictly to that guide, other times they don't. Cambridge does tend to hold you quite strictly to that guide. So for us, what we need to do is we need to declare each variable with its data type. So we're going to say declare. I'm going to say that 3 times. And then we need to say the variables. So we've got x, y, and z. And then we say colon, 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 and then we refer back to the question and say x stores a string. So a string. Y stores a position. So that's going to be a whole number. So we're going to say integer. And z stores a number of characters in the string, so that's going to be an integer as well. Okay, and that should conclude that one. If we check the mark scheme, have a little look. A little further down, there you go. Declare x as a string, declare y as an integer, declare z as an integer. So, like I say, if you're looking at it from a different exam board, they might ask you to write it differently. You just need to be familiar with the pseudocode requirements of that particular exam board. Question 12. So now we're starting to get into some of the slightly more programming questions. It is quite a jump from this to the programming question that comes at the end of the paper. But here we've got function length x finds the length of string x. The function substring xyz finds the substring of x starting at position y and z characters long. First character is x in position 1, right? So that's telling you quite a bit. It's telling you what all those parameters mean. Now you might need to look at this more than once in order to get a good grasp of what that means. But essentially we are defining a function here, or this is, they're saying there is a function which has these variables in it. Write a pseudocode statement to store string programming is fun in X. Find the length of the string and output it. And extract the word fun from the string and output it. So here's the thing about this question. A lot of times people are going to start this by going function and then substring and dot 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 dot. You don't do that. You don't do that because it hasn't asked you to declare that function. Okay, so a lot of people see this sort of thing and they think, right, that's what I've got to do. I've got to declare those functions. It will be quite specific with you if they want a function or a procedure declared. In this instance, what they're actually telling you to do is use that function. Okay, so it's this stuff here, which is the juicy stuff, right? Write a pseudocode statement to store the string programming is fun in X. So that's actually pretty straightforward, right? They're not telling us to get it from a user or anything like that, so we're just going to say X, and in Cambridge vernacular they like an arrow to say that our thing, in this case a sentence, is being stored there. Right? You should write the whole thing, I'm just cutting it short. Find the length of the string and output it. Okay, well, we've got a function to do that. It's up here, function x finds the length of string x. So what we're going to do is we are going to say output length brackets x. Now, I'd be curious to see how they would award marks here, but if this this variable here needs to match this one here. They've told you that it's x, so you don't have a lot of wiggle room here. But in theory, if you said, I don't know, banana here, and you said banana there, it would still work. Next, we need to extract the word fun from the string and output it. So here we need to know a few things. We need to know what x, y, and z do in this substring function. So let's get this nice and clear. So this finds the substring of x. So x is the string that's going in, right? So we don't need to worry too much about that at this point. Starting at position y and z characters long. So y is where we start. It's an index value. And z is how many characters we go for. Okay, so we want to get the word fun out. So we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to start in position 16. Okay, so it's not a bad idea to declare where we're going to start from. Oops. So actually they don't like that sort of thing. They like an arrow, and we're going to say 16. And then how many characters we want to go. 1, 2, 3. We want to go 3. So z is going to be equal to 3. Okay, and then all we've got to do is plug those things into our function. So we're going to say output, and then the name of the function, which is substring, followed by brackets. X is going in there, y is going in there, and z is going in there. Now there might be a little wiggle room here about how you do this, but broadly speaking, that's going to be lined up quite well with the mark scheme. Let's jump over and take a look. So 1 mark for storing a string in x. So x is equal to programming is fun, easy peasy. 1 mark for calling the function length. So length x, easy. 1 mark for using the correct parameter x. So if you use the wrong one, you can still have the one for using length, but you wouldn't have got x, you wouldn't have got the third mark. 1 mark for using the substring function. So this is down here. 1 mark for the correct parameters, and 1 mark for outputting length and substring values. So actually in hindsight, what we could have done is just plugged 16 and 3 directly into the y and z spaces, and you should still have got those marks. Okay, and that concludes question 12. Last question, and this one's a doozy. In the actual exam paper, they give you 2 or 3 pages to do this. I've sort of sliced it up so you can see it all here on one screen, but this is the whole question, and then you've got the marks down there at the bottom, just down here. The 1D array student names contains the names of students in a class. The 2D array student mark contains the mark for each subject. For each student, the position of each student's data in the 2 arrays is the same. For example, the student in position 10 in student name and student mark is the same. So basically what they're saying is we enter a name, we enter a mark. They're going to appear in different columns but on the same row. The variable class size contains the number of students in the class. The variable subject number contains the number of subjects studied. All students study the same number of subjects. The array and variables have been set up and the data stored. Students are awarded a grade based on their average mark, and you can see them there. Write a program that meets the following requirements. So we need to calculate the combined total mark for each student for all their subjects, calculates the average mark for each student for all their subjects, rounded to the nearest whole number. So not truncated, not just converted to an integer, it needs to be rounded. Output for each student name should be name, combined total mark, average mark, grade awarded, and calculates and stores the output, and outputs the number of distinction marks, passes, and fails for the whole class. You must use pseudocode or program code and can add comments to explain how your code works. You do not need to initialize data in the array. So we don't need to actually set the arrays up, but we obviously need to be accessing them. For a couple of reasons, I'm not going to start by trying to answer this question. I'm not even going to pick through this and pick out the key points, although there is some distractor information in here. A lot of it doesn't really matter to us, at least from the get-go. But what I am going to do is start by going straight to the mark scheme. On the mark scheme, this is marked quite differently. So you have assessment objective 2 and 3, and you've got mark bands for those, and there's a few things there talking about some of the requirements. Basically, this section up here at the top is all about requirements, what is and is not acceptable. You've then got this next section here where they're talking about required techniques. Now, these are things that they're looking for, so you need to be able to calculate total mark, calculate the average mark, selection of grade, etc. And you'll notice on almost every line there's a bracket at the end telling you like an actual programming technique. So iteration and totaling, and then for point 3, selection, so on and so forth. These are the things that they're looking for. Okay. There's then this next section here which says data structures required. So there's a few data structures that you need to use. They've given you the names of them in the exam, in the question. They haven't said you need to create them, you just need to acknowledge them. You need to use those exact names. I would watch really carefully for like capitalization and things like this, because especially if you end up mixing and matching, strictly speaking, those are different variables and you can end up getting marked down for that sort of thing. Okay? So that's that. If we shift a little further down, they'll show you some examples. So there's a pseudocode example, then I believe you'll get, in fact, this is all a pseudocode example. Okay, that's worth bearing in mind. It's likely that with a program like this, on an exam, the examiner is just going to be presented with pseudocode, and so they're going to be looking to match what you've done up with the pseudocode. You always want to be trying to make the examiner's life as easy as possible. It's not always possible. Sometimes you don't know. Sometimes you have no idea what's likely to be on the mark scheme. But if you can match it as closely as possible, it's easier for the examiner to find you the marks. And you want that. You don't want it to be a challenge for them. So I would encourage you to be writing in pseudocode, or I would encourage you to be writing in a language which is very close to pseudocode. I would discourage you from the sorts of things that your examiners are likely to be less familiar with. So you only have choices here between Python, VB, and Java, and I'd probably put them in that order. Python is quite close to the way they write their pseudocode. VB, I have to say, personally, I've got no experience with, or very limited experience with, but that will probably be your second best. It's going to be fairly similar in a lot of respects to the way this code is written. Java, I would say, is going to be your least favorite. Okay, Java is not JavaScript, it's Java. It has a tendency to be a bit more complicated in the way that it's written, and that makes it a challenge for the examiner to mark it, to compare it against the example code that they've got. So you want to stay away from that if it's even a choice for you, right? If you then come down, you will see that they are marking this using boundaries, if you like. They're looking for certain criteria. So not just that you've used these techniques, but that you fulfill some of these criteria. Now, the thing about this is, the advantage here is that your code may not work, it may not make logical sense. You may still be able to pick up quite a lot of marks, even so. Right? It shouldn't make that much difference if it's not perfect. Okay? That's just because of the nature of the way that it's marked. However, you shouldn't be going in there thinking, well, I can get this all wrong and still get the marks. Obviously, we want to be aiming for a perfect solution. Now, the way that your paper is marked won't be identical to this, but it should be similar. So you need to be able to pick out the key ideas from the exam question that you want to try and hit. They are not going to ask you to do anything which doesn't appear in the textbook or syllabus, right? So the skills that appear in the textbook or the syllabus are the things you want to make sure you're reasonably competent with. Selection, iteration, counting, totaling, input and output, that's broadly the skills required for the GCSE, okay? What will happen here is if you hit just these techniques, then you're going to be in the 1 to 3 mark grade boundary. If you use them a few more of them and you are applying them properly, then you will be in this middle boundary, and again, using them really well, you're going to be up here. This is essentially a numbers game though. More you use, the higher up you go. You'll also notice there's a category down here. Some data has been stored but not appropriately. This is looking at the arrays, the variables, etc. If you were to store things badly but use techniques well, that would be strange, but the way this is marked is best fit. So if you're up here and down here, you're going to end up somewhere in the middle. More common might be that you're here and here, for example. So you're in the middle and you're at the top. In which case they're going to look at, okay, well, if they've used all of these data structures and they've forgotten one thing that they should have saved, or vice versa. I've actually got that backwards, but they've forgotten one thing that they should have saved, then you're going to be looking towards the top of that middle boundary or the bottom of the top one, okay? And their judgment will be being called on at that point, okay? If we go a little further down, you've got another assessment outcome here. This one's a little bit more complicated, but it's going to be marked in the same way. So thinking about your appropriate names for things. They've talked about things being commented. This seems a little unfair to me because it does actually say in the exam, you may comment it to explain what's going on. It doesn't say you have to. Here, though, is where we start to get into essentially, does your program work? Like if it's in a logical order, it can be in a logical order and still not work, but that's going to be quite tricky for you to do. So if you've got your program laid out logically, you're going to be scoring more highly. Similarly, if you're somewhere in the middle, if it's partly logical, but there's other bits where you sort of drop the ball, you're going to be down here in the middle. Okay, and that's how it's marked, and it's quite important to bear that in mind. Essentially, what I'm getting at here is you don't have to have a perfect solution actually to score pretty well here. Okay, now if we scroll back, their solution here looks a little like this. Now you should attempt a similar sort of thing, right? So what they've done is they've declared everything they need to declare right from the beginning. So they've declared the various different data structures, variables, arrays, etc. Please take note of the way that they do it. If you're going to do it using pseudocode, you need to match up with their method. Okay. They've also declared constants. So constants are values that aren't going to change. In this case, it's the pass mark for each of the various different grade boundaries. They've also initialized a few things. So up here, they've declared things like, in fact, they haven't declared them, but down here they're saying, well, distinction number is going to be 0, merit number is 0, so that we can count those up later. We then have this loop here, which is going to essentially track the student. Which student are we looking at? Moving on a little further down, we've got this big block of code down here, which is doing the vast majority of this. Okay, now it's complicated. You've got loops inside of loops and whatnot here. And that's the sort of place where we can lose marks. You should try and view this particular question as a mini exam on its own. You're probably not aiming for all 15 marks, and you don't need all 15 marks to do really well here. If you're getting 10 to 12 marks, you're probably doing really, really well. Okay. Anyway, so we've got 4 student counter, 1 class size, 4 subject counter, 1 subject number. So student counter and subject counter, remember we've got names and subjects in different columns. So this is just taking account of that, right? This is looking at the first row, second column, or first row, first column, whatever. We've got some code here, total mark student counter is equal to total mark student counter plus student mark student counter. So this is just counting. This is the nth term. It's equal to itself plus whatever it is that we're actually looking at. Okay. And as you work through here, actually it begins to get easier and easier because a lot of the manipulation of the arrays is the part that's difficult. Once we get a little further down, we're essentially making a decision as to whether that grade meets certain criteria or not. So it is just an if statement. If the average mark for this particular student is greater than the value that we've got set for distinction, then we're going to count it, tell them they've got a distinction, and move on. Otherwise, we're going to check it against the merit, against the pass, etc., etc. Okay? One of the easy marks here to pick up is going to be outputting the right information. Now, maybe it's illogical, but the fact that it's illogical doesn't mean that you don't get marks. It just means that it's a little more difficult for you to get all of the marks. So just bear that in mind. Something which is included, like outputting the information at the end, is quite a good idea.